What if we will make machine learning continuous and distributed? What are the impacts and what we will need to solve as breakthrough to make that happen?
To me, like the most intriguing thing is like maybe there's like a biological metaphor there. We kind of think of all the thinking happening in the cloud today, and the cloud is sort of like the metaphor for maybe a brain. But really, if you like pull out the biology metaphor further, like not all of our thinking in actual animals happens in the brain. Like a bunch of it happens in the spine, a bunch of it happens in our eyes, a bunch of it happens in our fingers.
If you look at current AI, we have a few brains, big brains that are in these big labs producing these static weights models. But in the world, we have 7 billion brains that every single day they improve and they learn and they adapt themselves. So are we going to stay that way where we have these fixed models, that super big brains, or are we going to have smaller brains that continuous learn and adapt, that are distributed?
I think one of the fascinating things, if I were to riff off of that, is like, what does like social AI look like? Like where models have been co-trained with other models to perform learning and inference together, right?
So I think the next wave of distributed computing and continuous learning will be learning how this system communicate and how to learn to each other and how to protect each other from making mistakes. Right?
Yeah, so it's maybe the jump from like distributed computing to distributed learning or distributed inference.
Right. You wrote a very, very insightful blog on the relation between compute and data to scale this training model. So related to that question, so where do we find data now to train those models? Because we kind of extinguished all the data available to us.
I think a lot of people misunderstand the bitter lesson. To me, the bitter lesson fundamentally says two things. One is that architectures that can extract more intelligence per unit of compute, and two, architectures that can scale with additional compute win in the end. The second part, I think that's how most people interpret it. And I think there's a lot of work there, right? Like if you have, we have architecture that scale with compute, but compute scales as a square of data, and now we're running out of data. So if you just scale into diminishing returns, then there's nothing left. Yeah. I think world models and verifiable environments are fascinating places. Like how do these models learn to operate in 3D worlds just like we do, with consequences just like we do? And that is a very different world than next token prediction. I think the other part of this, the first part of this, which is how do models extract more intelligence per unit data, per unit compute, I think is actually an underexplored area. I think there's been some really interesting work recently. But among other things, one of the basic notions in science is this notion of parsimony. How do you build models that not just explain the world, but parsimoniously explain the world?